Okay, this is sample 6-1, Around the Bend, on page 231 in your book. And as usual, they're starting us off easy. That's okay. It says a sign posted gives a maximum recommended speed of 65 kilometers per hour for a certain curve on a level road. The curve is a circular arc with a radius of 95 meters. What's the centripetal acceleration of a car that takes this curve at maximum speed? Okay, so just to kind of place us, just get an idea for what this problem looks like. 65 kilometers per hour is probably about, I didn't convert, but about 40 miles per hour. So kind of fast for going around a turn. However, the circle is a radius of 95 meters. That's like a football field radius, so it's a pretty gentle curve. So we're going to find out the centripetal acceleration of the car. So we're given the radius of the circle or the turn, which is 95 meters. We're told that we have a speed of 65 kilometers per hour. Do your unit conversion and you get 18 meters per second for that. Remember, to do these problems, use the units correctly, you need to use SI units. So we've got to get to meters per second. And if you can't remember how to do that, refresh your memory, ask for help if you need it. Our formula for centripetal acceleration is v squared over r. That gives me 18 meters per second. And just because it's our first calculation this chapter, I'm going to write that out twice instead of just squaring it, because I want you to see that the units do cancel out. There's 95 meters. Okay, 18 times 18 divided by 95, keeping two significant figures, gives me 3.4. We know the unit's going to be meters per second, but let's just show ourselves. Let's get rid of that meter. We'll get rid of that meter, and sure enough, we are left at 3.4 meters per second squared. So that's about a third of acceleration due to gravity, which is pretty gentle. I mean, we live under 1g, so 1g is not going to cause us too much trouble. So this isn't going to be a huge acceleration. This isn't roller coaster acceleration. So just a couple of takeaways from this very simple problem. Make sure you have the radius of the problem. This book is going to give you the diameter lots of times. And sometimes you know a distance from here to here, and that distance is the diameter. So it's not a useless calculation. Make sure you can get from kilometers per hour to meters per second. That's going to be important with any sort of road problems with cars. And then also, like if we start talking about speeds of planets orbiting and things like that, you might see speeds in kilometers per second. So just be on the lookout always before you plug in a velocity into a formula that you have meters per second. So that's it for this sample, and we'll move on.